last lectures we had studied about electric field lines and electric dipole. We had studied a special type of electric field that is called uniform electric field. That is an electric field whose magnitude and direction remains same at all the points, and such a field is represented by a set of equidistant parallel lines. Now we have to study that if an electric dipole is placed in a uniform electric field, what happens? What is the effect of the electric field on the dipole? For this we have kept this electric dipole consisting of the charges plus q and minus q and of length 2L in the uniform electric field E. The dipole is making an angle theta with the direction of electric field. When this type of arrangement is taken, then what happens? Both the charges of the electric dipole will experience some force. We have to see the forces. Force on charge plus q due to its presence in the electric field is q into E, and force on the charge minus q due to its position in the electric field is F minus, that is minus q into E. Now we have two forces. The figure is showing F positive is acting in the direction of electric field and F negative in the direction opposite to electric field. These two forces, they are equal in magnitude, opposite in direction. So what will be their resultant? The net force comes out to be F positive and F negative, their vector addition, and this becomes 0. Because net force is 0, so what happens? The dipole will not have any linear motion. Any translatory motion means it will not move up, down, left or right. But what happens? The two forces F positive and F negative, they are equal in magnitude, opposite in direction, and also they are acting along anti-parallel lines. The direction of one force is this and direction of one force is this. They are not opposite like this. If the two forces are acting in this way, the resultant is 0, means no translatory motion is there, and also no torque will be produced by these two forces in total, and no rotational motion will also be there. But when the forces are like this, one force is along this and one force is like this, such two forces are said to be forming a couple. These two forces equal in magnitude, opposite in direction, acting in two different directions but along anti-parallel lines. So this type of pair is said to be forming a couple, and this couple will produce a torque as a single force does. The couple also produces a torque. What is the formula for that torque? Torque due to couple is either force, its magnitude. Out of two forces, any one force can be taken because they are equal in magnitude, into perpendicular distance between lines of action of the two forces. What is the perpendicular distance between lines of action of two forces? This perpendicular, if I draw from one line of action of the force F positive on the line of action of F negative, say this point is C and this is normal, then what the line becomes? Perpendicular becomes AC. AC is AB because ABC is right angled triangle. So AC upon AB, this is sine theta. So torque becomes Q into E into AB sine theta. What is this AB? It is the length of the dipole. So the torque becomes . the torque becomes Q into E into 2L sine theta. Q into 2L, this can be taken together and this becomes P, and E and sine theta. P we have written in place of Q into 2L. So this is the torque. P is dipole moment, you know it is a vector quantity. Electric field intensity, this is also a vector quantity. Torque is also a vector quantity, so we can write in vector notation, it is P cross E. So torque will be acting on the dipole when it is kept in uniform electric field, and this torque will be trying to rotate this dipole. In which sense, in which direction it will rotate? It will rotate the dipole in such a way that finally the torque becomes 0, or you can say theta becomes 0 when the dipole becomes parallel to the electric field. So what is this torque doing? Torque will try to rotate the dipole in the direction of electric field in such a way that finally this dipole becomes parallel to the electric field and torque becomes 0, or you can say theta becomes 0. So this is the situation when we say the dipole is in equilibrium. Now the dipole is in equilibrium means torque on the dipole is 0. This torque can be 0 in two situations. Torque can be 0 if theta is 0, and torque can be 0 if theta is 180 degree, because sine theta is 0 as well as sine 180 is 0. In this situation, when theta is 0, then dipole is said to be, in both the situation dipole is in equilibrium, but dipole is in which equilibrium? It is stable equilibrium. And when theta is 180 degree and torque is 0, then dipole is in equilibrium. But what is that kind of equilibrium called? It is called unstable equilibrium. This. So what is the difference between stable equilibrium and unstable equilibrium? In stable equilibrium, suppose this is the electric field, uniform electric field, and this is the dipole. This is negative charge and this is positive charge. What is the direction of dipole moment? Left to right. What is the direction of electric field? Left to right. What is angle between two vectors P and E? They are parallel. And when they are parallel, theta is 0 and torque is 0. If because of any change, if the dipole is rotated or turned, suppose in any direction like this, if it is turned anti-clockwise or clockwise, what will happen? A torque will start acting on the dipole, and that torque will bring the dipole back to this position, this orientation. If the dipole tends to come back to its original stable equilibrium condition, because after any disturbance, what is this called? Stable equilibrium. But what happens in the case of unstable equilibrium? This is the diagrammatical representation. Electric field is the same and dipole is like this. This is minus q and this is plus q charge. The dipole moment will be acting like this, right to left. The two vectors are anti-parallel, angle theta is 180, torque is 0, equilibrium is there, but this is unstable equilibrium. How do we understand it? So in unstable equilibrium position, the dipole moment is in direction opposite to the electric field, that is P is anti-parallel to E and theta is 180 degree. In this condition, if the dipole is rotated in any one direction, clockwise or anti-clockwise, then what happens? On releasing, the dipole will not return back to the original orientation, rather it will turn and becomes parallel to the dipole, parallel to the electric field, that is the stable equilibrium orientation. So in stable orientation, stable equilibrium, the dipole on disturbing returns back to the original state, whereas in unstable equilibrium, any kind of disturbance, any kind of rotation, if the dipole is released after that, it will rotate through 180 degree and return back to stable equilibrium position or orientation. This is the difference between stable and unstable equilibrium.